Okay, let's get concrete about this. Let's look at the specifics of how we both define a class and then implement instances of that class. So if we want to define our own type, we're going to start by using the keyword class, not surprisingly. And that's going to tell us we're about to create the definition of a new class. So we're going to start with the class definition. We're going to give it a name. In this case, I'm creating a coordinate. That's simply an XY pairing of points in the plane. And then each class definition is going to take one argument, which is the parent class. And initially, we're going to create classes that inherit from the underlying object class of Python. So we'll always just have object here. When we start building hierarchies, we'll see that we want to extend that idea. But just to repeat it, I've got a class definition, I've got a name, in this case coordinate, and its parent, in this case, is object. It's followed, as always, by a colon to tell me I'm done with this. And then immediately below that, I'm going to define the attributes of this class. And I'm going to have them indented, as always, to tell me where the bounds of that class definition lie. Now, the word object means the coordinate is itself a kind of Python object. And that means it's going to inherit all of the attributes of the underlying Python object. We'll come back to that in a second, but that's going to be valuable. One last piece of nomenclature. We say that a coordinate is a subclass of an object, and an object is a superclass of a coordinate. We're going to have a subclass inherit from its parent or superclass object. So, simple start, define a class with a name and an object. Now I have to get into how do I actually put attributes inside of that class definition. So first of all, what are the attributes? Well, they're going to be data and procedures that belong to this class. If I take my example of a coordinate's got an x and a y value. So I'm going to have some data attributes that are the x and y values that are associated with a coordinate. What I'm going to do is think about those data attributes as other objects that make up the class. Things that get inherently glued together and can be treated as a unit. A point in the plane is a unit. Happens to have pieces in it, but I want to have that class capture those things together. So as an example, while a coordinate is made up of two numbers, a coordinate itself is something that I can use. Those are the data attributes. We also need ways to use the data. And those are what we call the procedural attributes or the methods. Think of methods as functions that work only for this class. So for example, if I want to compute the distance between two coordinates, I could do that, and I can do that in a second, define a distance method associated with coordinates. But it doesn't typically make sense to think about doing distances between strings or distances between lists. I'm going to create a method that belongs only to this class. And it's going to be seated inside of that class as one of the procedural attributes associated with the class. Okay, so how do I do that? Well, first thing I've got to do is define how I actually create instances of this object. And for that, we use a special method called init. And in fact, it's written a very special way. It has got two underscores, the word init, and then two underscores. We're always going to do it that way. It's a special method. And this special method is going to create an instance when I actually use coordinate as a call. Now, what's inside of init? Its first argument is a parameter that's going to refer to an instance of the class. And by tradition, we always call it self. In fact, you'll notice when you type it in, the Python environment always types self in a different color and in a different, in this case, italic font to distinguish that it refers to an instance of the class. We also want to give this thing that's going to create instances the initial data. If a coordinate has an x and y value, I want my creation of an instance to take in a value for x and a value in y, and we're going to glue them together. And the way we glue them together is we're going to actually create bindings for the names x and y to the values passed in. And what you can do is think of this as when we actually invoke the creation of an instance, which we're going to do in a second, this will bind the variables x and y within that instance to the supplied values. I'm going to come back in a second to why it says self.x and self.y. But think of this as saying within that instance to which self refers, I'm binding x and y to the values passed in. This is typically the first method that we have inside of a class definition because we have to say how am I going to create instances of this class. This is also inherently defining the data attributes associated with this particular class, an x and a y value. Okay, Let's make a couple of versions of this. So I'm actually going to do that. I've got over here on my machine a definition of coordinate. And I can now create an instance. I can say I'm going to let C be a coordinate. So I simply use the name coordinate. Oh, and that's nice. Notice when I did the open paren, I'm going to do it again before it disappears. It tells me what the arguments are that are expected. And I'm going to give it two, an x and a y value, 3 and 4. I'm going to define origin to be the origin of my coordinate system. So it is another coordinate of 0 and 0. And notice, each time I invoke coordinate, the name of a class, it's creating a new instance. What it's doing is it's calling that init method and using that to create local bindings. Now, you might notice here that there's no version of self. Wait a minute. Didn't I have in my definition, the definition of init was self, x, and y? I did, but the style or the process, if you like, in Python is that self automatically points to the particular instance that I've just created. And Python automatically provides that argument for you. So when I call init, I only call it with the arguments that I need to provide in order to create the data attributes. Once I've got that, I now have instance variables inside of that class instance, and I can get to them. So for example, I could say print out the x value associated with C. And there it is, 3. Or I can print the x value associated with the origin. And there it is. Just printed it out. Think of this as C giving me an instance. It did because I created it. And now I'm going to try and get the x thing associated with C. So I create a new instance of an object. I pass in the arguments. I use the dot notation to access an attribute of an instance. And what I want to think about is what does it mean to do that actual accessing? As I already said, notice that the argument for self is automatically supplied by Python, so I don't need to provide it. The way to think about this is as follows. Think of C, an instance I created with coordinate. Think of it as pointing to a frame. You may remember we saw that when we did function calls, that every time we called a function, we created a new frame. In essence, a class definition is doing that as well. Coordinate is creating a new frame associated with C. Within the scope of that frame, we bound values to data attribute variables. So inside of C, there is a binding for x and a binding for y, to 3 and 4 respectively. C.x is then interpreted as saying the following. Get the value of C. Oh, that's a frame. And then inside of that frame, look up the value associated with x. So C.x says, get the value of C. That's a frame. Now I'll use the next thing to say what's the binding for x inside of that frame. And thus that's going to make it easier to understand why C.x gives me back 3 and origin.x gives me back 0. In each case they're referring to a different frame in which the variable x is bound. And just like with functions, there was no confusion about which binding to use. Same thing with different instances of the same object type.